Hello, friends. So today we're going to talk about pages 602 and 603 in our science book. So today it's all about tampering with temperature. That's a little tongue twister right there for you. So I'm going to start talking over the page. So I need you to follow along whenever I tell you to do something. Please have your pencils and highlighters out. That way you do it as I'm telling you. Okay, so let's go ahead and get started. When a burner on a stove is really hot, it glows red. A change in color is just one way temperature can affect matter. Okay, with the act of reading with your pencil, I need you to underline. As you read this page, underline examples of how temperature affects physical changes in matter. Okay, let's keep that in mind. The physical changes in matter is what we're underlining, the examples of it. Okay, I'm going to start reading the paragraph, so I need you to follow along with me with your highlighters. So, some physical changes, such as tearing a piece of paper, are not affected by temperature. Other physical changes happen faster or slower at different temperatures. Okay, with your green highlighter. How quickly a change occurs is called the rate of change. Put a little star by that for me over here on the outside. That way you remember that later on. Okay, for example, in blue highlighter, ice on a lake will melt at the air temperature if the air temperature is above 0 degrees Celsius. Okay, you can put that blue highlighter down. It will melt even faster if the air temperature is warmer. In pink highlighter, in the same way water condenses more quickly on the outside of a very cold soft drink can than it does on a cool one. On a cool can, sorry. You can put your pink highlighter down. Okay, so I'm going to look at that first example, that first photo with the rod. Okay, so wow, this metal rod has been heated to more than 500 degrees Celsius. So when converted into degrees Fahrenheit, that would be 932 degrees Fahrenheit. That is extremely hot, you guys. That's probably almost maybe as hot as lava, but we never know. So the hot. So that iron is heated. When it's heated, it glows red or yellow. So let's backtrack here really quick. So when metal or iron is heated up to a glowing red or yellow color, this means it is in a state that it can physically be bent or flexible and made into different shapes. Okay, so let's go on to that not the second, but the third example. It's of that little light bulb down there. So, ouch. So, right here. So, ouch, this filament of a light bulb is made of a metal called tungsten. So, it is glowing because it is heated to 2,500 degrees Celsius. You guys, that's extremely hot. Like, extremely. Trust me. Okay, so let's think back to that active reading really quick. So it said to underline examples of how temperature affects physical changes in matter. So let's backtrack here. So we have three things we need to underline in the paragraph and one thing we need to underline in one of these two examples. So let's go up here to the top paragraph. So, where would that first thing that we need to underline be, you think? Think for a second. Okay, so we're going to be underlining right up here. Happens faster or slower. Sorry, my line's a little messed up, but I know y'all can read that. Okay, what would be the second thing we need to underline, you think? Take a second and think. Yeah, so we're going to underline melt even faster. So it melts faster. So what's that third thing we need to underline, you think? I'm going to give you a second. Yeah. Condenses more quickly. Okay. And the last thing we need to underline, what do you think that is? It's somewhere in one of these two, examples. Yeah. It's down here. It's where it says glowing. Because when it glows, you can see that bright color. That's a physical change because it glows. It's a pretty color. So let's take a second to review here. So if metal or iron is heated to an extremely high temperature, you can see the physical color change. But once iron and metal has reached this high temperature point, this means that they're also flexible and easily made into different shapes. Okay, let's move on to page 603 now. You can put a giant green X over do the math. Whoop, whoop, you don't have to do that today. That's your free pass. Woohoo! Okay, so let's move on. So we're going to talk about that. We're going to talk about the bottom half of this page. So I'm going to read the little paragraph, so work with me. When grass and the air around it cool at night, water vapor in the air might condense, forming dew. As morning sunlight warms as morning sunlight warms the air, the dew evaporates. In this photograph, the grass in the shade is wet, but the grass in the sun has dried. So let's look really quick. Okay? So right here in this photo, we see that it is dry. There's nothing on it. So that means the sunlight has, hit the grass and there's nothing on it. But the grass over here that's under the shade in this tree has water on it. So it still has that dew on it. Okay? Since that sunlight has not reached that grass yet, what do you think that would be? Yeah, the warm temperature hasn't reached it yet, so it has not what? Yeah, it might not has. I'm so sorry. Let me backtrack there. It has not evaporated yet. There I can go. So sorry. So I hope that helps. If you have any questions at all, please email me or private message me on Google Classroom. Please make sure to take a photo of both of your pages and submit them as a file on Google Classroom before you click the Turn In button. Thank you very much. I hope you have a great day. I miss you guys so much.